Good morning, everyone. This is Bruno from FAMIC Technologies. I'd like to start off by thanking everybody for attending the first webinar of our series on Automation Studio 9.0. I see more of you are connecting, so we'll just continue as scheduled. So here we have three webinars that we'll be doing in this series. So the first is this first webinar that we'll be covering today. We'll have two more webinars. They'll be every Tuesday next week and the Tuesday the following week. And we'll be covering different topics that have been made available in version 9.0. So this is the topics that we'll be going over today. So basically some of the new functions in 9.0 related to oil volume variation, some of the stuff related to bill of materials and reports, some new component appearances, so some enhancements that have been done in version 9 on some stuff that we had continued to work on in version 7 and 8. Some new updates for the manifold workshop, and then we'll conclude with a Q&A session. So just to remind you guys, if anybody has any questions, what they can do is just use the questions box. That way we'll be able to answer your questions during the course of the webinar. If you raise your hand, we'll just ask that you use the question box instead. It'll just be easier for us to manage. The webinar will be recorded, so everybody who's registered will be able to get a copy of the video that's accessible to them after the webinar's been completed. So usually it's about a day or two after. Otherwise, it'll be posted on FAMIC Technologies website in due time. So without further ado, I'll pass things over to my colleague to start the presentations.
Okay, thank you. So this feature is the ability to simulate the variation in the volume of fluid as a function of temperature. Okay, so let's say if we want to evaluate the evolution of temperature in a project like this one, first we need to turn on the thermal evolution in the simulation options. In the hydraulic installations, we also have this setup. So we have an ambient temperature of 50 degrees Celsius and an initial fluid temperature of 25 Celsius. So this will lead to an increase of the fluid temperature by heat dissipation. We start the simulation. So we can see that the fluid starts at 25 Celsius and its temperature is gradually increasing. We can also see that the density of the fluid is changing with temperature. Here I've increased the thermal coefficient of components just so we can see things happening a little bit faster. But what we don't have right now is a variation in the volume of the fluid. So here we can see the height in the tank does not change. So that doesn't completely make sense physically. We should also see an increase in the volume of fluid in this closed loop as soon as the density decreases, aka the specific volume increases. So previously, we didn't really worry about that too much. For example, for pressure drop calculation, well, the density of the fluid is the parameter that has an influence. But for some components like reservoirs, cylinders, accumulators, this can be a problem. So for this reason, in version 9, we now have the option to also turn on the thermal expansion of the fluid. Okay, so if we simulate again, now we can see the density changes with temperature, but so does the volume, as we can see by the height of fluid in the tank. This increase in the volume now is entirely due to thermal expansion. We can also see the effect of this on the pressure in the tank, which is pretty slowly rising. And if we were to let this go for some time until the closed volume becomes saturated, we will see the pressure build up fairly quickly. Okay, and we'll see this in cylinders as well, for example. So here we have a mass pushing downwards on the piston and the fluid is trapped. So initially the weight has compressed the fluid a little and then the piston slightly retracted, but then the volume increase builds up pressure and that is generating a higher force on the piston side than on the rod side. And so the piston extends very slightly, but we're able to measure this. We can also see the measurement of the compressed volume on the piston side increasing. So with this example, we can simulate what happens, for example, if a machine is left in the sun for a while and the fluid is heating up, we can show how the cylinder piston will slightly move due to that effect. So, okay, so now this is taken into account in components, and this includes the volume in the lines as well. So in the case of lines, there's an additional option. There is a threshold in the project options, meaning the lines with a volume below this value will disregard thermal expansion. This is mainly to avoid running this calculation in every line of the project, which can consume computer resources not necessarily needed. Okay. And one last thing to clarify, when we say thermal expansion, it does include, of course, the volume variation both ways. When the fluid cools down, we will also see a contraction of the volume. So that covers the essential for this. We can move to the next topic. Okay, so this next feature is the possibility to display fields in bill of materials and reports in multiple languages at the same time. So here what we have is an example project with a bill of materials already started with some configuration. We can see we have the component name property of the components used as a BOM field, and it's actually repeated 3 times in 3 languages. We have English, French, and Spanish. So we are using for this the translation manager found here, which is in the first place a tool that allows users to enter user translations for text and display them in a chosen language, depending on who the project is shown to, independently of the current language of Automation Studio's interface. But the translation manager can only have one display language at a time. So what's new in BOM and reports is that you can now add a user translated property as a field, refer it to an existing property, and choose a language locally for this field. So I'm going to do here is add another description for a few of the components in the BOM and have it display in 3 languages. So I'm going to go back to the translation manager for this. First, I'm going to import the translations from the central user database into the project by transferring their dictionaries. Okay, so these are the translations I'm importing into the dictionary of my project. We select the ones we want and we apply. I could also directly import them in the project from a CSV file. Okay, so they are now added to the project along with the ones that were already there. Apply, close. So now in the BOM, in the fields, we're going to add the catalog description property in 3 languages. So the values for this property are already entered in the components in that property in English. So first we're going to add the user translated property in English. So we add a field, a user translated property, give it a name and an alias. And then refer it to an existing property, which is this one, and select in which language it should be. Okay, we see it up here. So then I'm going to do the same thing but in French. Add a user translated property. Refer it to the same property. display language, and finally in Spanish. We apply. Okay, so we now have the value of this field for the relevant components translated in multiple languages at the same time, independently of the current display language of the translation manager and of the interface language. So they're always displayed in multiple language at the same time without having to change any other language setting. And of course, the same thing is also possible in the spreadsheet reports. So we can see here it is already done. So that's pretty much it for this. Moving on to the next topic. This next feature is the ability to display highlighting colors in area of component symbols to identify some functions or states, including in simulation. So if we start with this circuit, so we have a clean black and white schematic, nothing else. First, what we can do is we can turn on the highlighting of the fluid lines. So with that, we can see with the configuration of standards that was already done in this project, how we can separate more clearly the different line functions, such as pressure lines, return lines, suction, etc. Then what we can now do is we can turn on this highlighting for components as well. So now we have, while in addition mode, the mobile parts highlighted in blue in the symbols, such as the cylinder pistons, and most of the other component surfaces shown in a light gray color. If we start the simulation, now we can see colors starting to show up in some components. First, we have a dark gray for inactive states and yellow for active states. We see which spool positions are currently in use in directional valves. We see the engine is turning, but it is not transmitting to the pump. Engage the clutch. So now the variable piston pump is activated. We can see the pressure colors in the volume of the control piston, also in the fluid side of the accumulator. It's also showing another color to indicate a pressurized gas on the other side. We can see a few other valves and other elements show the active yellow color when there is flow or when they're doing their main function. So we can see the color of the different activated components and the color of pressurized volumes. There can also be a distinct color in lines and component volumes to indicate a trap pressure when it's above a certain threshold value. So these different colors come from the configuration in the project properties. There is a category of standards for component appearance where all these things can be customized. So we can see here the colors that we have seen on the various parts of the schematic. The symbol, line, color, and thickness can also be modified. And this standard can be attributed by type of component in the document standard. So we could also choose to have some of those appearance attributes vary for some type of components. So just for pumps, let's say, And those things are now possible for components of the hydraulic, pneumatic, mechanical, and control libraries. So for all those components, we can use those colors to show more clearly some functions or states in a system. And so just by changing a document standard and turning on properties, we can quickly turn a black and white schematic into a training or technical publication document. Last thing to mention about this, it's possible to modify the configuration of those highlighting areas in the symbol if there is ever the need, or to add it in older symbols where it might be missing. For example, let's say I want those piloted check valves to show the active color in the whole box. I open the configuration tool, add it, and apply, and that's it. And so that covers the essential for this feature. And that's it for me. So thank you, and I'll let my colleagues continue.
Thank you. We'll now take a look at our new Manifold Workshop updates that are available in version 9.0 and in the SR1 update. So I have opened a simple manifold block here in the Manifold Workshop, and this block contains um, a custom component from the Manifold Elements catalog. And this is where we're going to take a look at our new feature, which is the use of step files for generic components, uh, in addition to other components such as the port components. So if you have used the custom components in the past, you will know that they come with a generic shape that is positioned on them. We can access the dimensions of this generic shape by right-clicking on it and accessing the 3D model parameters. And we can see uh, some properties where we can define the dimensions of this generic shape, have it either be cylindrical or rectangular. And now with version 9.0, we also have access to the external 3D model feature and the no 3D model feature. So if we chose to, we can select no 3D model and have no 3D model appear. In this case, we're going to take a look at adding our own 3D model. So I can click on the 3 points here and I will be able to load my own step file for this component. So I simply double click and then we'll be able to see our step file positioned inside of our cavity. In this case, due to how the step file was created, it's positioned correctly right in our cavity. There are cases where you'll have to adjust the position, and we're going to be taking a look at that now. So I have a port here, an SAE8 size port. I can right click on it and we'll see we have the 3D model parameters command that is also available. And I can go here and I'm going to add a fitting into this port. So I double click on my fitting step file and it will be added in proximity to my cavity, depending on how the step file was created. So we can see here the positioning of this 3D model is not correct, and it's even in interference with some other components inside my block. So what I'll do is I can click on it, and then we have access to a new group of commands. And the one that we're going to use right now is the positioning command. So if I click on the positioning command, I'll enter a new mode. And if I enter into flat view and select my component, I'll be able to rotate it uh, with this view as a reference. So if I choose to rotate left, I can see that I now have the orientation that I want. All I have to do is adjust the position of the model with respect to the cavity now. So I can zoom in a little bit, click and drag, and simply position my model in my cavity how I want. So if we're happy with that, the next thing I can do is either click on the escape command on my keyboard or click on the positioning button over here to exit the view. Uh, that window. The next thing we need to be aware of is that all 3D models have interference outlines. So in the View tab, we have our Outlines command that we can choose to toggle these on and off. And these interference outlines are used when we position our components either manually in order to determine if we're respecting our clearance rules that we've defined in our options, or when we auto-create to respect those clearance rules when we generate a block solution. So if I go back to my Design tab, you'll see that in the 3D model group, we also have access to an Outlines command. So if I click on that, we'll enter a mode where if I enter in Flat View, I can adjust the dimensions of this outline, my interference outline. And I could choose to make it bigger or smaller or adjust its dimension however I want. And if I wanted to, if I could right click on it and then reset it or delete it using these commands over here. I'm happy with this, so I can either click escape to leave this mode or click on the outlines command once again to exit. So now I've showcased this use of generic use of step files to replace our generic 3D model or to add a 3D model to components like ports. The next thing we're going to want to take a look at is, as a new feature, is the ability to add section views that we can use then in our technical drawing documents. So you may have noticed, in addition to this 3D model group of commands, we also have another new group of commands, which is the section views group. And what I can do is, let's say I want to take the section view of this valve, for example, of this cavity. I can go onto this top face and I can add a cutting line. So we have access to the ISO cutting line or the ASME cutting line, depending on whatever you choose. I click on it, and now if I click and drag on my document, I can create a cutting line. So I just click and it's created. And then I can adjust it if I want to, just by clicking on this blue cube, and it'll snap to a point that's parallel, to have a line that's parallel to the right or left face of my block. So I have that there. I'm happy with that. And then I can exit my cutting line mode. And this will allow me to now adjust its position. So let's enter a flat view over here, and I can snap it to the center of my cavity. So you can see it snaps to that center position. And now you can see that when it's not selected, I don't have access to this cutting area command. But if I do have it selected, I have access to this cutting area command, and I can click on it. And what it'll do is it will bring me into a specific flat view mode where I can draw the specific cutting area that we want. So I can do something like this over here. Click on my endpoint, and now I have a cutting area defined. I can adjust it, or when I'm happy with it, I can click escape, or once again on the cutting area command to exit that mode. And we can even see now our cutting area on our 3D block. So the next thing that I'm going to want to do is I can go to the View tab, and I can choose to hide this. So if at any point I don't want to see my section view on the 3D model, I can toggle it on and off. And then when I'm ready to go to my technical drawing and place it on my drawing, I can enter my document. And if I open the Library Explorer, I can see that my view is being generated for the first time since we just created our cutting area. Once it's created, I'll be able to simply drag and drop onto my drawing document. Now I can zoom in a little bit, and I can go and show some new commands that are available on our drawing documents. So these commands will be related to the annotations. You may be familiar with the ordinate dimensions and the linear dimensions that we can add currently to our multi-view projection. We also have the ability now to add angular dimensions. And to add our angular dimensions, what we're going to want to do is create some axes within which to measure that dimension. So if I click on my axis command, you can see I have some anchors that are automatically created. I can choose to create new anchors if I wanted to, but I'm going to use these existing ones for the moment. So I can simply click on an anchor and click somewhere else, and I'll have an axis created. And if I choose, I want to snap it to another anchor, I simply just move it, and you can see it snaps to another anchor. And I'm going to do the same thing for this other side here, something like that, and adjust my axis until it snaps. And then I can toggle off my axis command when I'm happy with what I have. Next, I'm going to create my angular dimension. So I click on my first axis, click on my second axis, and I have an angular dimension that's created. We also have the ability to adjust this dimension. So if I wanted to show 43 degrees, for example, on this, I simply right click on my dimension value and click set angle. And I can adjust the axis, one of the axes to have my new angle. So I put 43 and I want to adjust my axis 1 in red. If I wanted to, I could adjust the color simply by clicking here if you wanted to do that for representational purposes. I click apply and I have the angle that I want displayed. The next thing that I can do is I'll also mention that for the normal dimensions, the ordinate and linear dimensions, you also have the ability to adjust this dimension as well. So you'll have you can right click on the dimension value and set dimension to adjust its value that's displayed on the drawing document. So the next thing we can take a look at is going to be the title block editor. So let me just delete this. If we see in the bottom of our document, we have a title block. In the past, we used an XML file to create our title blocks, and users could go in there and create them manually by adjusting the XML file to position lines and texts. But now we've simplified this greatly. So if we access either our default drawing options in our default options or on our current drawing, so I click on my current drawing setup, we'll see that I have some new commands that are available in our title block section, which will be the modify the current title block command and create a new title block command, and then delete if we wanted to. In this case, I'll just click on modify the current title block to showcase these features. So what's important to note is that a title block consists of a frame. So if I select this, this is the frame. And you can see that in the drawing commands, we have these frames that we can insert. So you can have multiple title blocks on one, or multiple sections of the title block on one document. So if you want one in the bottom right, one in the top left, you can have that. And we also have different text that's inserted as well. So if I double click on something like this metric, the unit system, it opens up a properties window where we can see our three different types of properties of text properties we can display in our title block. So we have a project property. So this can either take something from our project parameters document, such as the material we're using, or it can take something like the unit system, which is selected when we first create our manifold project. You have a list of different properties that you can select from, and these will be automatically taken automatically from the software. You also have access to a user editable text. So this comes into play in things like the description over here. So if I double click on it, we can see that I can open up its properties, and we see this is a user editable text. And if I open up the title block property dialog, we can see that these description lines are modifiable by the user they don't appear in gray. So when we're going to exit our title block editor mode, we'll be able to adjust those values if we wanted to. And then finally, we have simple text. So things like the description here, which is just the title of this section of the title block. If I double click on it, there we go. I open up the properties and we can see this is a simple text. So by using lines, we can create our different sections. We can add logos for our company if we wanted to. And then when we're done, in this case, I'm just gonna exit our, first let's showcase actually, I can adjust the position. So if I wanted to move this to the top left, I can very easily do that just by clicking on our map locator reference and put top left. And then you can see that it's adjusted its position. So very, very simple. I'm going to exit the mode without saving. And here we'll cancel that. And we can see our title block. If I were to double click on it, I gain access to the window that we saw before where we can adjust certain information. We saw our description line, so I can put the ABC. We can modify it as we choose. And this covers the new title block editor and the ability to create custom title blocks very easily. A next new feature that we have available is the improvement to the database system for block cost calculation. So if you're familiar with the two systems that we have available, we have the Excel price calculation, which basically exports the machining parameters into a template document where you can then take all the values and calculate the prices using your own formulas in Excel. So it's basically you have the full power of Excel to enter your own formulas, do anything you want. And we had our SQL system, which used some formulas that are predefined in the database. And we wanted to add some more features now that we have the Excel price calculation, to add some more features which make it more powerful. And these will be, so if I open up my database over here, we have new tabs that are available, to new tables, which are the machining time for cavity and machining time for drilling. So previously, if we look at our block price rules, we had calculations, for example, for the cavities, which will be the number of cavities multiplied by a cavity coefficient defined in our coefficient table. In the case where we add a machining time for a specific cavity into this table, so you just add that VC08-2 cavity, for example, and it takes 1 minute to machine. If we do that, then what will happen is that the formula will change, and it will instead use the coefficient for cavity price per minute multiplied by our machining time multiplied by the number of cavities. So we have the ability to have a more refined formula for our cavities or for our drillings in that case. So we can see that for the drillings, the same thing for different diameters. Depending on the unit system, we have a drilling time that is available as well. In addition to that, just some simple drawing features that were added to end here. You have the ability to add splines on your drawing documents. You have the ability to add arcs that you can adjust however you would like. And you also have the ability to create polygons as well. So this covers the new Manifold Workshop updates for version 9.0 and SR1. And now we'll move on to the next section, which is the Q&A. Thank you.
Good. Thank you, Nikolaus, and thank you, Philip, for the presentations. So again, we'll be moving on now to the questions and answers section of this webinar. Again, I remind you, if you have any questions, feel free to post them in the questions box. What we'll do now is we'll go through some of the questions that have been posted and answer them throughout the rest of the time that we have here. So we have one question here. Okay, this is regarding the first presentation. This is questions for Phil. I think the fluid density also changes with pressure changes. Can Automation Studio simulate this? I think, Phil, you might still be muted. I don't know if you're with us.
Yes.
Okay.
Okay, let me make...
Yeah, I don't know if you heard the question, if you need me to repeat it.
Yeah, it's good, thanks. Yeah, so sorry for the misunderstanding. So currently the density does not change with pressure. It changes with the temperature. It was already changing. What we've added is that now this is the effect of that on the volume is taken into account. But the density does not currently depend on the pressure. So that aspect has not really been requested thus far. So if there is a need, we can look into that. There can be a request for this development, and you can see if you have any sources for the science on that. So to demonstrate it, right now, if I vary the temperature, the pressure in this point, and my thermal evolution is off, so temperature is not changing, we can see the density does not change at all. So it's the one aspect that is currently not considered.
Good. Thanks for the question and the explanation. We have another question here. If the expansion in a closed volume causes the pressure to increase, is it possible to receive a warning? I don't know, Phil, if you're speaking, you're currently muted.
Yes. Yeah, so that's a good question. Okay, so yes, you can. As always, if you check the option in the simulation options to get warnings for faulty components, what this will do is this will monitor the value of each component's maximum pressure, maximum flow, maximum temperature properties. They all have, most of them, those operating conditions properties. It will monitor this value and it will trigger warning when this is exceeded. So to demonstrate it, let's say in my cylinder, I will exaggerate. I'll put my maximum pressure to 3 bar just so we really get there faster. And I'll also remove the load, my kilogram, I'll set to 0 kilogram. So we will only see the pressure build up from the thermal expansion here. Yeah. Just making sure, yeah, I had turned it off. So, okay. So now we're seeing the pressure rise from that, from thermal expansion. And when we get past the maximum pressure, 3 bar, we get this little warning sign. It also gets listed in the message explorer with a reference to that redirects you to the component. So yeah.
Good. Thanks for the answering that question. We have a couple other questions related to the bill of materials. For what you had shown basically on the bill of material translations. Is it possible to create a translation for any property in the bill of materials?
Yes. Yeah. So yes, as long as the user translations for the values are in the project dictionary, they can be translated.
Okay.
Yeah, sorry. And it's also not limited to standard component properties. It can also be done with user-defined properties. As you know, you can add user-defined properties. Let's say I add a global property to all my components. I'll just name it test. So now I add this custom property to all my components. So if I open up the properties of a component, now I have this test. I could populate the values here, and in the BOM, I can also, if I had a user translated property, I would just name test, I can select as the reference property the custom property that I have added. So I won't do it now because nothing will show up. I don't have the translations ready for that. But you can also have user translated property fields for custom variables on components, and also for document properties. So these properties here that document documentation properties on documents can also be user translated fields. Thank you.
Good. We have one more question here. Okay, maybe I'll ask this question on the BOM, then we'll move back to the simulation questions. Is it if you, for the translation database, if I have an Excel with translations, can I use this in the translation manager?
Yeah, sure. So as I mentioned briefly, you can import translations in a dictionary from a CSV file, either in the project dictionary or the central user translation database. So here in my translation manager, what you always have is import dictionary. So either in the general database where I already have a few terms, or specifically in this project. So you browse and you bring up your list of terms in CSV. For example, I have those. I would select to add them to my dictionary. I won't do it now. Yeah, so if you have it in a CSV file, you're able to import it. And of course, if you want to know the expected format of the CSV file, the easiest thing to do is always just to pick any existing translation and do an export. So send this to some CSV file, and then you will see how it's supposed to be layout, what the fields should be, and then populate that CSV file, import it back into your file.
Good. Thanks for that explanation, Phil. We have two more questions about the simulation. I think this is kind of related to the first question that was asked. Can you simulate pressure change in an accumulator circuit for temperature changes?
Yes, I'm pretty sure you can. If, well, simulate pressure. Yeah, well, if you get a pressure change from a temperature change, so if a temperature change causes an expansion that leads to a rise in pressure, it will be simulated by the accumulator. I guess one easy way to do this would be to add an accumulator in this project. Yeah, sorry, of course I need my library components. So the accumulator also considers the thermal expansion of the fluid. I will also put, no, not here, I'll put the normally closed shut-off valve here. And as soon as there is an initial volume in the accumulator, right now I'm still in this project where I have heat dissipation with the ambient temperature. So naturally my temperature is rising. And so there is thermal expansion occurring with the fluid volume of the accumulator. We can see it's slowly rising to 0.05, so it's very slowly. So if I increase the precision of that, so I'm getting a little pressure variation in this value. So to do this faster, what I would actually need to do is exaggerate the heat transfer coefficient. Okay, and we can see a small pressure variation due to the variation of the temperature.
Okay, very good, Phil. We have one more question here. Let me see if I can read it properly. Yeah, continuous high pressure will result. Continuous high pressure will result in temperature rise, and ultimately will result in oil density change. Does Automation Studio have the capability to show this?
Yes, if what is meant by the question is, so in order if high pressure results in temperature rise, and then this temperature rise result in oil density change, then yes, this is taken into account. For example, here, if I have if my oil is going through this orifice that I set to be a smaller diameter, don't pay attention to the warning sign here. Okay, so I'm having a considerable pressure drop through the orifice. And so this is causing a rise in temperature. And this, of course, causes the changes in the density of the oil, which then increases the phenomena of the thermal expansion occurring with the volume in the lines and the reservoir. We can see the height in the tank rising. If I set this even narrower, yep, my temperature increases way faster now. I'm also getting those warnings as I still have the option turned on. And I can see the effect on the fluid density here. Yeah.
Very good, Phil. Good. I see there's a couple more questions that we have here. There's a question that we have that's a little bit on a different topic that you had demonstrated, Phil. It's related to the component appearances. So the question is, so you're saying those criteria on colors can also be different depending on component type?
Yes, correct. So for example, let's say here we go back to the component appearances standards, which are here. Okay. So what we can do to demonstrate this is I'll just make a copy of the default one, and I'm going to change a few things in this one. So I'm going to say that in this components appearance standard, the active component color instead is going to be some orange color. And also the criterion for the color of the hydraulic volumes now is going to be flow instead of pressure. Okay, but now I need to assign this. So then in the hydraulic standard of the document, I'm going to assign this to the pumps, the instruments, linear actuators, and the instruments. Type by order. Okay, yes. So now when we simulate this, so now we can see that my instruments, my pumps, when they're active, they're in orange instead of yellow. So the other components are still using yellow when they want to show when they're showing the active state. And also, if I energize some actuators, we can see, but not as clearly now, that for actuators, as well as the volume of fluid in the piston of the variable pump, The color is now based on the flow. We can't see it as clearly, but maybe if I pause, so the colors now are not the same as not always the same as the ones in the lines. The lines are still going by pressure, but now the volumes in the actuators are going by flow. So you can configure those to be, all of those appearance settings to be different depending on component type. So just as a reminder, all of those colors are coming from the line appearance standards. So those were primarily intended, those colors are primarily intended for lines. And so this is where they are coming from. So we can see where those colors are coming from when you're going by pressure or going by flow. Those colors are with the threshold values. This is where it is coming from. And you can also go by speed or velocity of the fluid in the lines, as well as temperature. In the case of component volumes, internal volumes of components like a piston, rod volume of the actuator, it can be either by pressure or flow, or you can set it to none also. That's it.
Good. Thank you, Phil, for that explanation. We have another question. This is I think I would feel maybe a generic question on Automation Studio. I'll let you answer. To check the operation and simulate failures in hydraulic, pneumatic, or electrical control systems of a machine, is it possible to download the manufacturer catalogs? The manufacturer's drawings directly into Automation Studio, or do the drawings have to be originally executed in Automation Studio?
When we're talking about drawings, I'm not sure if the question is if you already have a schematic completely created externally, if this gets imported, let's say like as a DXF file, it will not be recognized and matched to actual Automation Studio components. But so in this case, if that is a question, they will need to be recreated into AS. But of course, using the catalogs, you're able to browse through all the libraries of different manufacturer components and build your circuit from that. And the characteristics are already modeled in. And if you want to check the operation and simulate failures, you'll be able to test that using the components, all their specific properties. And of course, using the troubleshooting module, you'll be able to add failures to any of those components, whether they come from the general library or particular manufacturer components.
Mm-hmm.
I'm hoping that answers the question.
Mm-hmm. Maybe we can showcase just really quickly the online catalogs. So I don't know if everybody knows that these exist. I'm presuming vast majority of you do know that the online catalogs exist. Maybe we could just showcase it really quickly.
Sure. So you always have access to the catalogs here. So it opens in your browser, and I've got all of those available manufacturers. And so then you browse from by manufacturer, and you go get any component. So I'll take a simple direct acting relief valve with back pressure. And so you configure your specific part number based on the reference model code from the manufacturer. Of course, this model code configurator here refers to what is found in the manufacturer's specification, which is always linked in the catalog. So this is what is replicated in our catalogs. And you configure your options, your properties, and then all you got to do is drag and drop into your circuit, and it's ready to use. So in this here, I would use this particular relief valve instead. Can move aside the part number. So this particular properties of that component are modeled in the component, including any characteristic curves, in this case, simply pressure drop curves. And of course, since we're talking about simulating failures, of course, we can add failures to components. There are specific failures depending on the nature of the component. For a relief valve, it will be those failures. And of course, you can add a general failure that is valid for any component. So you could add leakage, that would be external leakage. Maybe increase the parameter, it would be at port T. Then I need to declare and activate that failure. And then when I simulate, well, here the result is very obvious. I've got no flow coming out of the relief valve because I think I put quite a high leakage coefficient. So now I think I'm losing all of my oil out. Maybe if I decrease the pressure based on the coefficient, I'm still allowing some oil, but if I do my flows balance, no, I'm still losing quite a bit of oil because of this external failure. So of course, that will result in problems for the circuit. Of course, I'm losing oil. So if I come and measure the height of the oil in my tank, I will see, well, no, in this example, I've used an infinite volume tank, so I would just need to change this setting in my tank. But of course, yes, you can declare failures on components, including manufacturer catalog components.
Good. Thanks for taking the time to go through that, Phil. Okay, I think we have another question here. Hi, a very interesting webinar. I'm trying to change the appearance of the cylinders of my project, but I cannot achieve the same appearance that you are showing. Will it be because there is a special cylinder, or should it have the same appearance for all type of cylinders? I'm using a double effect cylinder with multiple ports. Yeah, if you're having some issues, getting the same appearance as what we're showcasing, do feel free to reach out to us afterwards. These webinars, we can always go online with you to figure out what's the case. Keep in mind that these new features are available in 9.0. So if you're not able to achieve some of those behaviors, it might be because you're running maybe an older version. So I don't know, Phil, if you wanted to comment on anything on that, or for this question, you prefer to treat that outside the.
We can have a look outside, but it's quite possible that you're looking at a special cylinder, the double effect cylinder with multiple ports. I believe it has its own separate builder, and maybe it is unfortunately one of the few components that was left out for the moment of for the appearance. So if it's something that you need, you can reach out and we can see if we can have that developed to complement this feature in an upcoming version.
Good. Thanks, Phil. Okay, we have some questions related to the manifold. So I don't know if for Nikolaus, will the technical and production drawings, will the technical and production drawing documents be exported in DXF format?
Not in this version, but in our coming SR2 version that will be coming soon. We have added the ability to export the production and technical drawing documents in DXF format.
Okay. Very good. Will I be able to add my part list to the title block?
So in the upcoming SR2 release as well, we've added some dynamic tables that will be filled automatically as you complete your project. And those tables include the part list and the revision table. So when you're editing your title block, you'll be able to add these sections to your title block, which will automatically fill in these tables. So for the revision, as you create revisions, it will automatically add lines. And the same goes for your part list. As you add components, they will be added.
Okay, thank you. And I think we have one more question here. Okay, this is a thank you. You're welcome. Is the only way to view the pressure in our manifold during simulation is by hovering the mouse over the specific point?
In the current version, yes. In the next version, SR2 that release again, what we're adding similar to what Philip was showcasing with the dynamic measuring instruments, where he was showing differential pressure and pressure at certain points. We're going to have that available, those similar types of tools available in the 3D as well. So you'll have these dynamic measuring instruments that you'll be able to position and always see the value displayed on a label.
Okay, very good. So just a reminder again, so for everybody who's attended this webinar, we appreciate your time and spending with us. We hope that we were able to answer your questions to the best of our abilities, and it's been helpful for you. Of course, if you have other questions or topics that you'd like to get into, feel free to reach out to us anytime. We're always happy to assist. I believe there will be a little survey afterwards for this webinar. If anybody wants to complete it, we always look to collect feedback on what some of you are interested in seeing for other webinars that we have planned. So again, we'll be doing the next webinar on February 25th, and that'll be next Tuesday. We'll be covering some of those features. So thanks again for all of you for attending, and we hope that the webinar was useful. Until next Tuesday, bye-bye for now.